Welcome to NeuroCheck, the machine vision platform. This video provides an introduction to NeuroCheck's Deep Learning Toolkit. The software is a standalone tool for managing your AI projects, labeling image data, and training AI networks. The AI networks generated with this tool can be seamlessly integrated into NeuroCheck programs and combined with rule-based algorithms. Let's have a look on how to use the toolkit. After you have successfully completed the installation guide, run Start Platform with PowerShell. The web application starts in your preferred browser. I log in with my admin account. There is a list of existing projects that I have already created. They cover various network technologies: classification, anomaly detection, object detection, and segmentation. Let's create a new user profile. Go to Users and click Create. Then type in a name and a password. Select Operator. Unlike the admin, the operator can only access its own projects. We may also add a profile picture. Next, we log out to switch to our tutorial account. As you can see, the projects are now locked. Let's create a new project and call it Segmentation Tutorial. As project type, we choose Segmentation, and we may also add a thumbnail image. When opening the project, we see the essential project characteristics summarized. First, we need to add our image data under the Dataset Settings. The image data is filtered and structured by labels. There are 4 subset labels for images: unassigned, training to train the model, validation for measuring the performance of the model, and test to further analyze the model. Click Add to load your images. Select their corresponding subset and drag and drop them into the box below. Next, we need to label the images. There are 4 tools for labeling. Rectangles. We are asked to create a new label. We call it Screw. Circles. Polygons. And automatic selection. Let's delete the labels in order to label our images properly. You can shortcut the labeling by using the number keys to assign labels. Here I am pressing the 1 key to select the screw label. You can navigate through the images using the arrow keys. To speed up the process, I load a prepared dataset that is already labeled. The images aren't assigned to a subset yet. We can do this by clicking on the crossing arrows. I choose to assign 10% of all images to test, 70% to training, and 20% to validation. By selecting and deselecting labels, we can filter the image list. In case you want to delete images, you can select them and click Delete. Now we can go on with the training. There are plenty of configuration options. Click on the question mark to get more information about the parameter. I set the number of epochs to 30. I choose half of the size of the original image. Here you can choose the architecture and the layer depth of your model. The layer depth is shown by the number at the end of the model name. Fewer layers mean faster inference and less size, but lower accuracy. The batch size determines the number of images that are processed simultaneously to speed up the training duration. Under Data Augmentation Parameters, you can stock up your amount of training images by adding artificially altered images to your dataset. Click Save to save your current training settings. Let's click Start to begin with the training. Once the training is completed, we open the TensorBoard. Here you can view the training results. Under Scalars, you find statistics on your model's performance. Check or uncheck the runs on the left to filter your results. Under Images, you find the final confusion matrix, and there are example result images. Prediction showing your model's result and ground truth, your original labels. We go back to the toolkit and enter the analysis settings. Here you can apply an existing model to your test images from the dataset. Select a model and an epoch. By default, all images from the test split are loaded. Let's start the evaluation run. We can check its results with TensorBoard. If you are satisfied with the training results, you can continue to export the model. Select the model and choose a checkpoint by clicking on the 3 dots next to it. Click Export. It will automatically be saved in your download directory. The ONNX file format can directly be loaded in the NeuroCheck's software. Let's open the demo application, AI Segmentation Torques. We open the parameter dialog for the Segment Objects check function. There, we browse for our newly trained model. Here you can switch between CPU and GPU as inference hardware. The results are output as regions of interest, so they can be further processed by NeuroCheck's various algorithms. Let's go back to the toolkit. You can also export the entire project as a zip file by clicking Export on the top menu. The file will be saved to your Downloads directory. Go to Projects, then Import to import the zip file to your project list. This way you can transfer your project, just like a NeuroCheck project, to another PC. Next, we create another project with the project type Classification. This time we predefine our own classes. We add a class called OK and a class called NOK. Then we add our images. My image list is already sorted, so I can choose the class OK for my first stack of images and the class NOK for my second stack. If we click on an image, we can label it manually by clicking the label or by pressing the assigned number key. The training is pretty much equivalent to our segmentation model. That was a brief initial look at NeuroCheck's Deep Learning Toolkit. If you require in-depth training or pricing information, please contact sales@neurocheck.com. Thanks for watching and see you in the next video.